Hello guys, welcome to another video in Python GUI programming with Tkinter. In today's video we're going to create a Python calculator app with a user interface, and you can see the final product right here. I'm just going to quickly demonstrate it for you what it's going to do. +2, 4, all clear. Yep, this is what we're hoping to create at the end of this video, so stick with me. I hope you enjoy it. Alright, so the first step, we're going to import some packages. So I'm going to remove this. I'm going to say step 1. I want to import some packages. Importing packages. Okay. So the first package we're going to import, it'll be Tkinter. Import Tkinter as TK. Alright, so Tkinter, as you might know guys, is a Python user interface design module. So we use it for designing our application and creating a GUI interface. And the next one we're going to import, it'll be functools. So I'm going to say, actually we want to import partial class from functools. So I'm going to say from functools import partial. Okay. So the functool module, which is included in Python standard library, it provides essential functionality for working with like high order functions. Those functions are functions that return a function or take another function as an argument. So we're going to have one Python high order function example in our code today. So when we get there, I'm going to tell you about it. It's going to be partial. So partial, basically, we have partial functions versus Lambda in Python in our today code. The partial function, which is part of functools, it's used to freeze some portion of a function argument or keyword, producing a new function with simplified signature. So let's say, for instance, we have a function with 5 arguments. We want to predefine 4 of them, so we want to declare them as constants. We don't want to change their value, and we just want to keep changing only one of the arguments. So using partial function, we are kind of able to do that. So when we get there, when we get to our example, I'm going to demonstrate for you guys how it works, and we're also going to cover Python Enumerate example. And I'll also provide more details when we get there as well. So for now, let's go to our next step. After importing our packages, we want to create a main window application. So step 2, I want to create main window application. Okay. Always have typo. Alright, so to do that, I'm going to declare a variable called root. It's going to be a root window. I'm going to say tk dot tk. Actually, it's tk. Okay, and I wanna define the size. I don't want to make it resizable, so I want to make it not to move. I'm going to say false, false, and false. So this will help us to, when we run the app, when we get the user interface, when we get the window, this will disable it to be expanded. So we can expand it from width or height. We can't like change the size of the window, because I'm creating like a calculator. I want it to be, I don't want it to move. I don't want it to resize. Just prefer it that way. So I'm going to run this root.main loop, and let's run it now just to see what is. Okay, so you can see if I try to resize as I can, because I set these to false. That can happen. Can't happen. Alright, so this is our step number 2. Step number 3. Step number 3. I want to create a label. Okay. I'm gonna create this label just for a few reasons. This label will be where we display our like result or display the numbers. You see when I show you the app before here, so like 2 plus 2, you can see it here. So I'm going to use the label to display these numbers and display the result or whatever we're displaying in this portion of the user interface. So whatever we're displaying it here, we're doing that with the help of this label I'm going to create. Okay, so I'm going to say lbl tk.label, and I'm going to pass it to root. We could have created like frames and passed each one of these to the frames, but I just wanted to keep it simple. It really didn't matter. Okay, and I'm gonna position it. I'm gonna say LBO grid. I'm gonna use grid here. So row, go to row. Okay, row. I want to be 0. First row column. Also want it to be 0. I'm going to say column span 4. So this will expand, like it's going to span 4 columns. It'll take space for 4 columns, starting from column number 0. And I want to say path x equal to y and path y. So I want to have 5 from, okay, I want to have 5 from top. So I'll have to put it in parentheses. I'll have 5 from top and 1 from bottom. Okay, we can also define, if we want to define top and bottom, we do it like this. We put it into parentheses and we can just define it, giving it 2 values. Okay, so the reason I didn't give any value in our text here, because we're going to use a function to keep changing this later in our application. So whenever we clicked on something or whenever we pick the number button, this will get updated. So for now, we're not going to get any value. We're going to define a function later that will do that for us. So let's go to our next step, which will be step number 4. In this step, we want to create number buttons. Okay, so we had a layout of 3 at 3 for, you can see here, for 1 to 9. I want to create this portion from 1 to 9, like 3 in the row, 3 in the columns. Yeah, grid works as the row and column based, so we use grid in a row and column format. So, but we're gonna get into that a bit later. We want to create our widgets, like our buttons here, and there are a few ways to do so. So the most common way would be the easier way would be just define them one by one and give them the grid location, like the row and column and all that. We can do that, but it'll takes more time and it'll be it'll be harder then to read our code. It's harder to maintain our code. So I'm gonna use a different approach to code less and makes it more efficient. So first I'm going to go ahead and create a dictionary called buttons, and as you guys know, dictionaries are key value pairs. So we are going to create button from 1 to 9. and we're gonna create 0 separately later. I'm gonna create the 0 button later in the code. Just wanted to do from 1 to 9 now. So we need to assign the text and do all this dynamically. We want to create a loop and go over it one by one. So I'm going to say for I in range 1 to 10. This will go from 1 to, okay, this will go from 1 to 9. This is how the loop works. Okay, and I'm gonna say buttons I, and I'm gonna say tk dot button, and I'm gonna pass it to the root, and I'm gonna define a text for it. Okay, so we use the button class to create any buttons, and what I did here, like as you guys definitely know, I'm passing each iteration value to this dictionary. So at the first iteration it will be button 1, so this will be 1, then all the way till 9. So this is how we can reference our buttons later in our code. So for the text portion, we're going to assign the text dynamically, so I'm going to give it the I, but I'm going to use F formatter. Okay, I'm going to use F formatter so I can pass the I value here. So this will get displayed on the button, and we want to have height for our button. We want to define their height. I'm gonna say height. Let's give it 2. Width, let's give it 4. And here we want to have a function when the button clicked, and we want to pass a value to that function. So then we can use it to display it, to do our calculation, to do all the operations that we're supposed to do. So we pass any function using command, but the problem here is that we can't just pass a function with the argument. Like, it doesn't work. So let's say if I say display btn, this would be our function. We can't pass any argument here because this is not how the command works. And we have few ways to bypass that. We can use partial functions versus Lambda in Python, as I said earlier in our code. This is where we use one of those. So I'm gonna go with Lambda for here. I'm gonna show you partial later in the code. I'm gonna say Lambda, and I want to say num equal to I, and display btn. I want to pass num here. So Lambda is a anonymous function that can take any number of argument. We only have one argument here, so we can't pass I here directly to the display btn, because I is the reference to the value, and it keeps changing at each iteration. So at the first iteration it's 1, at the last one is 9. If you pass I, we're only going to have 9 at the end. We're going to have the reference to it. We're not going to have the actual value. So to have the actual value, we need to pass it to a variable and pass that variable to our function. Okay, so let's also go and let's go and define our function. So I'm going to come all the way up here, and I'm going to say, I'm not sure which step would this be, but let's say diff display btn. I'm going to just say pass, so we won't get any error. Okay, we should be good here. And in the next step, we wanna use grid to arrange these buttons that we created. So I'm gonna go here. I'm gonna say buttons again. I, and actually I'm gonna say grid. Okay. Okay, so since we're passing the values dynamically, we're creating buttons dynamically, we need to get a little creative here. So we need to passing the grid row and column index. For row index, I'm going to use, let's say, row equals to, I'm going to say I, which is our current button, minus 1. I want to exact divide this by 3, and I'm going to say plus 1 again at the end. So for column, actually, I'm going to say I, current button, minus 1, and I'm going to go with modular 3, and I'm going to say pad x equal to, let's say 1, pad y equal to 1 again. All right. So I'm going to explain to you what is happening here. I used I minus 1 exact divide by 3 plus 1 for the row. So why did we do that? So we want to arrange in rows such as each row contains 3 buttons, and we want to have 3 rows. So the first row should be 1 to 3, and second 4 to 5, and third 7 to 8, 7 to 9. And to achieve this, we need to calculate the row index based on the current button number. So the expression I minus 1 exact divide by 3, which will effectively group the buttons into row of 3s. And adding 1 to the quotation, to the expression at the end, make sure that we're starting from row number 1 instead of 0, because we defined row 0 to be for label, for where we display our operation and number and all that. So what is happening essentially here is that, let's say for instance in the first iteration we have 1, then we're gonna subtract it by 1, it'll give us 0, and then we exact divide. So the exact divide will remove any fraction from the result. So if we have, let's say, 1.2, it'll remove 0.2, so we'll have 1. So 1 minus 1, it'll give us 0, and exact divide by 3, it'll give us 0 again, and we do a plus 1 here, and it'll return 1. So button number 1 will be placed in row number 1. Again, if we go this, the same thing will happen for 2 and 3. So let's say we have 3 minus 1, it'll give us 2, exact divide by 3, it'll be I think 0 point something. So essentially it'll give us back 0 again, and we add 1 to it, and we have 1. Same thing happened from 4 to 6 and 7 to 9, but it'll give us 4 will give us 4 minus 1 will be 3, exact divide by 3, it'll be 1, so plus 1, it'll give us 2. And 5 and 6, same thing will happen, but we will have 2 point something for 5 and 6, but since we're doing exact divide here, so it'll give us 2. I'm sorry, it'll give us 1, but we add 1 at the end, so it'll be row number 2. Okay, so for the column, kind of same logic, but we're removing 1 from it, modular 3. So when we say modular 3, the result would not go over kind of 2. So for 0, for the first iteration, for 1, we'll have 0. Modular 3, it should give us, I think, yeah, it'll give us 0. And if we have if we go to the next iteration, if we have 1 here, 1 minus 1, again, it's 0 in modular 3. So it won't go past 2. And so that'll help us to put every button from column number 0 to column number 2. That's the plan. That's what we're trying to do here. But we don't need to start from column number 1, because that doesn't matter. That's why I didn't add 1 at the end. And pad X and pad Y, we just give a little space from top and bottom and left and right. Yep, that's how I did arrange this. We could have done that, all of this, for each button separately, one by one, but as you can imagine, there would be a lot of coding and a lot of space would go to waste. So I think this would be a better option. So we're gonna go to step number 5. We want to create these buttons here, the operator buttons. So I'm gonna come here, say step 5, create operator buttons. Okay, so the way I'm going to do it, I am going to again use a loop. I'm just not going to go do it one by one. First I want to define a list and assign them to there. So I'm going to say a list. The first one would be plus, the next one would be minus, next one would be star, the next one would be for division. Alright, so I'm not gonna include equal sign. I'm gonna define that separately. Okay, so let's say for I want to use something called Enumerate. We said that we're going to have Python enumerate examples, so this is it. So enumerate is a built-in function in Python that allows us to keep track of the number of iterations. So instead of we track them, it'll track it for us. It works like it returns a pair of index value, where the index is the position of the item and in the sequence, and the value is the actual item. So I'm going to say I op in enumerate, and I'm going to pass the list I have here. Let's say operators, and so I represent the index of the current item in the sequence operators, and OP represent the actual value in the current sequence of operators. Okay. So this kind of allows us to loop over operator list while also having access to the index number. Let's create our buttons. I'm going to say btn op equal to tk, again button class. I'm going to pass it to the root. Text would be the operators, and height would be let's say 2, width, yeah, we want to give it the same size as before. Command. Okay, so as mentioned before earlier in our code, we can't pass argument directly when using command. So as I said, we have two options: partial functions versus Lambda in Python. So last time we used Lambda, and this time I want to use partial function that we imported from functools. So functools.partial allow us to create a new function with some of the argument of an existing function pre-filled. In our case, we're gonna say, let's say cmd equal to partial, and I wanna call the display btn function we created before, and the argument I wanna pass op. All right. So in our case, we're passing the display function to it, and with the op as the argument. Okay, and I want to pass this cmd to here. This is way easier. Okay, and last step, we need to arrange these. So I'm gonna go ahead here. I'm gonna say btn op dot grid. So for the row, I want them to be from row number 1 to, let's see, to row number 4, I think. So 1, 2, 3, 4. Yep. This equal sign, we do it later. So I'm gonna say I, which would be 0 at the first iteration, plus 1. This would be our row, and column, I want all of them be on the same column. So 3 pad x, I give 1 before, same here, pad y, 1 again. Alright, this is our operators. So step number 6. Step 6, what we want to do here? We want to define whatever is left. So we had number 0, we have equal sign, we have all clear button, and we have dot. So we're going to define these. We want to do this one by one. Okay, step 6, create other widgets. Alright, first we need the button. Oh, we also need button number 0. So button 0. Okay, this was supposed to be 0. Equal to tk.button. And I'm gonna pass it to the root. Text is 0. Okay, I'm gonna need to put in quotation. Oops. 0. Okay. Alright, so, and next thing I want to define the height equal to 2, width equal to 4, same as before. Command, I would go with Lambda, just it'll be faster. Display btn, I want to pass to it 0. Okay. Alright, so btn 0. Where is 0? Okay, here. Grid. Row number would be, let's put a number 4. Column 1, pad x 1, and pad y would be, I want to give it 1 from top, 5 from bottom. Okay, so this is our 0. So let's go and define dot. Say btn dot equal to tk dot k dot button root text would be dot, and I'm gonna give it height of 2, width of 4, same thing. Command would be lambda equal to display btn, and I'm gonna pass to it dot. Okay, this should be here. Okay. Next we have, let's define our AC button, btn AC. Let me put it AC. tk dot button root text. It will be AC. Height, same thing. Height 2, width 4, and command. We need a new function for this. This will clear our label. It'll clear our display. So I'm going to say clear this. Let's go and define it here. Let's go say diff clear this, and I want to say pass. Okay, then we need to arrange this. I'm gonna say btn ac dot grid. Say row number, let's say 4, column 2. Okay, column 2. Pad x 1 and pad y. It will be, I want to give it, let's say 1 from top, 5 from bottom. Last button, guys. Last one, btn equal. I'm gonna say tk dot button. I want to pass it to the root. Text would be equal height 2, width 4, command lambda display btn, and I want to give it, okay, come on, equal sign. Okay, and btn eq dot grid. I want to put row number 0, column 3, and pad x 1, pad y, let's do it 5, 1. Okay, and yep, our code seems to be finished at this part. So we need to head over step number 7, define these two functions. So I'm gonna call this one step 7, calculate and display. This one, step number 8. Step 8, clear display. Okay. Okay, step number 5. We first need to define like a variable here because we're getting argument. I'm gonna call it clicked button, and I'm gonna remove pass. So first we need to retrieve what the label is displaying right now. So we can say current text, we say LBL, which is the name of our label. I'm gonna say cget, which will retrieve whatever we put in here, which would be text. So retrieve the text from LBL. Now we can display the current text plus whatever button the user clicked and pass it to our argument in the function. So we're going to say new text equal to, I'm going to use F formatter, I'm going to say current text, and I want to say click button. So we're displaying whatever they're inputting, they're clicking. And we need to say lbl.config, and we need to assign the text to new text. Okay, so this will help us with the displaying and inserting these values into the label. But the one problem is that we have two problems actually. The first problem is that we're also passing equal sign. If you remember, down here in our code, we're passing equal sign. I don't want to display equal sign. I don't want to display it. When the user click on it, they get the result. So we need to fix that, and we also need to do the operation itself. To do that, first of all, we need to define a global variable so we can constantly update it. If we don't define a global, the value get back to the initial state. So we need to define a global variable first. So to do that, we need to just define a variable outside of the function scope and give it a value, which I did here. Then we go to our function, we say global, we change it to global. Okay, global, come on, operation. And now we want to define a condition to fix those two issues we were having. We're going to say if we get equal sign in new text, I want to do this. First, I want to say, let's say operation would be equal to, I want to use a function in Python called eval. The eval function will take a string and return an integer. So in our case, we can pass the string to it and it'll do the operation and return the result to us. So we have these stuff here, these variables here, all as a string. So the new text is a string. Okay? So if I pass it to eval function, let's say the new text is 2 plus 2, and then the user click on the equal button. So 2 plus 2 equal button. If we can remove the equal button sign, the equal operator, then we'll have 2 plus 2. Then if we pass it to eval, the eval will treat this as an operation and it will give us 4. It will return to us the result of a string as an integer. So I need to remove that, the equal sign, and then pass it to eval. To do that, I'm going to say eval new text, and in order for us to remove it, we're going to use something called slicing. So I'm going to say -1 here. This means that remove the last character from the string. If it's equal sign, see, we give a condition here. If it's equal sign, this will happen. We'll go here and this will get executed, and we have, since we know there is an equal sign, we're going to just remove it. Using this will remove the last one, the last character. And I want to say new text again. I want to pass it the new whatever we define in operation. And then I need to use the config again. Config to display it. Go to config, go to text. Now go to config. Then go to text option, and I want you to display new text. Okay? This is what we have. Now, if I go to, I'm just gonna define an else too. So else operations equal to new text. We don't want to leave operation empty. All right, so this is it. This is all good. The operation will happen here. The equal sign will get removed, and we're good in that area. So we need to go to step number 8 and just clear the display whenever you user click on the display on the AC. So this is very simple. We're just gonna say lbl.config, go to text, and nothing. Empty quotations. Yep, there you have it, guys. We are done with this code. You see, it's not that long. It's pretty. We really made it readable. This could have gone way longer if we didn't use these loops here to create the buttons. So I'm happy with the way we coded this. Right, so let's run our application and see our final result. So I'm going to come here, run. Okay, let's say 2 plus 2 equal 4, AC 2 minus 2 equal 0, AC 5 multiplied by 5 equal 25, and 8 divided by 2, it'll give us 4. All right, great. It'll does whatever it's supposed to do, so we're good there. Great, so that was it, our Python GUI programming with Tkinter. I hope you liked this video, guys. Please, if you enjoyed watching this video, give me a like, subscribe, or comment. I would really appreciate that. Till the next time, happy coding, guys.